Hey guys, my name is Alex, and I'll be teaching you guys the rules of exponents and then giving you a few examples on how to simplify them. Before we start, it's important for you to know what an exponent is. An exponent is a whole number that indicates how many times a base number is to be used as a factor. Our first rule is the product rule. Example of the product rule would be a to the x times a to the y equals a to the xy. Then we have the quotient rule. Example of the quotient rule would be a to the x over a to the y equals a to the x minus y. Next is our power rule. This would look like open parentheses a to the x close parentheses to the y equals a to the xy. One of the easier rules to remember is the zero rule. This would be a to the 0 equals 1. Finally, we have our negative exponent rule. This would look like a to the negative x equals 1 over a to the x. Easy. Problems 1 and 2. Okay, so what we have inside of our parentheses is x with the exponent of 2 over 3, and then outside of the parentheses we have 3 over 5. What we're going to do is just take 2 over 3 times 3 over 5, because we have to distribute. And then if we cross cancel the 3's, we're just left with 2 over 5. So this gives us x with the exponent of 2 over 5. Super easy. Our next easy problem is open parentheses 6 to the negative 3. Then we have to distribute in our 4, which gives us 6 to the negative 12. Because of our negative exponent rule, we have to plop this underneath as our denominator, which gives us 1 over 6 to the 12. Medium, problem number 3. Okay, first we have 2x squared y to the third over 3x times 9x squared y to the second over y to the fourth. So what we're going to do is take the bases of the numerators and multiply them together, and then we're going to add the exponents of the like bases. So 9 times 2 gives us 18, and then we have x to the fourth from x squared plus x squared, and y to the fifth.
Since we have no like bases on our denominator half, we're just going to have 3x y to the fourth. Then we're going to take our numerator and our denominator and divide 18 by 3, which gives us 6. And we're going to subtract the exponents of the like bases, which gives us x to the third and y with the understood 1.
Hard. Problem number 4. So, we first have x to the negative third y over z squared. On the outside of this, we have a negative 4 exponent. We'll have to distribute this in, keeping in mind that there is an understood 1 on the outside of y. This then gives us x to the 12th, y to the negative 4th, over z to the negative 8th. This is when we flip our negatives, which then gives us x to the 12th, z to the 8th, over y to the 4th. Thanks for watching!